I am the Nature Hacker, and this is your world. Today I want to talk about rockets don't work in space part 6 in this series, and I want to talk about today the relationship between a water jet and a rocket jet, and how they are not the same and how they're going to have different effects. So a lot of people who are trying to prove that rockets work in space are saying that, well, look at a water jet or something, you know, like I saw one person with a video have a hold the shower head in his hand and turn it on, and it jolts back, and then turn it off and it goes back here and jolts back, and just like that without actually really pushing on anything. You know, like it's far away from the bathtub and whatever. Or, you know, a fire hose example, where, you know, it's showing a reactionary force. Well, what I'm going to tell you now is that, yeah, water can act as a Newton's third law device. I mean, water can sustain a reactionary force. It's all about, if you watch my other videos, it's all about being able to sustain a reactionary force. And, you know, we know that we can stand on a skateboard and throw a shot put ball and move a little bit. And the reason I'm going to tell you, the reason why you can do that is because when you're pushing on that shot put ball, the shot put ball can sustain a force. The shot put ball can sustain, it is a mass, obviously, right? And it can sustain an acceleration. So if the mass can accept an acceleration, can sustain acceleration, then you get Newton's third law effect at equal and opposite reaction. Even so, it's really low power. You know, just the Newton's third law effect is very low power. So if you had a jet ski and you put wheels on it and you're trying to ride around town in it, you're just going to be going around at a very slow speed. You know, just you're going to be getting all of your motion, all of your acceleration from Newton's third law, and you're going to get a lot less than actually if you're gaining friction in the water with your jet. So the Newton's third law effect does work for incompressible things, you know, like you can throw a shot put ball. And the reason why you have to be able to apply a force to your object, okay? You have to be able to apply a force to the object. In order to do that, it has to be a mass and be able to be accelerated by, you know, pushing on it or whatnot. So that's how a shot put ball works according to Newton's third law. That's how a water jet also works according to Newton's third law. Since water is incompressible, just like the shot put ball is incompressible, you know, you can't really, you know, compressible means squeezable, you know, if it's really easily squeezable or not. Water is considered to be incompressible. That means that if you have it contained, you cannot squeeze it at all. All right? And, you know, we could think about the containment of liquid, and if that would actually apply. But as long as the liquid is contained enough, you know, there is some surface tension in any kind of water stream. There's surface tension, so that's applying containment to the stream, to the water. Sorry, I just ran out of storage space. As long as your thing is being actively contained, you can push against it. So it will work as a Newton's third law device. So the shot put ball, its mass is not moving out of the ball. You know, the mass is contained in the shot put ball, so you can push against it. Okay, in water, the mass of the water is contained. It's contained by surface tension, and it's incompressible, so you can push against it. Okay, so just because water works according to Newton's third law does not mean that gas works according to Newton's third law. But then a gas in space, let's just say in space, a gas is not contained. It will expand indefinitely to fill any container. It will expand indefinitely at its maximum possible rate to fill any container. That means there is zero surface tension. There is zero containment on the gas. Alright, now there's zero containment on the gas. Now, where I want to go with that is that since there is zero containment, you can't push on it. It cannot sustain a reactionary force. You know, there is mass present, yes, but when you push your hand through it, the gas particle here, you know, when you push your hand through it, the gas particle is going to maybe move a little bit and come back. You know, you're not pushing, you can't push anything because you cannot, there's no friction. You know, in an ideal gas situation, in a vacuum, there is no friction to be able to push the gas. You know, it will just, you know, when your hand is going by it, let's say my finger right here, I can't do two things. Let me see if I can set my thing here. Okay. So I'm pushing. So here's the gas particle. I'm pushing my hand, and it's just going to move the particle out of the way. You know, it's just going to. I can't push it forward. There's no friction. It's not gaining any traction on my hand to move forward. It's just going to go around it. You know what I mean? So you can't push against the gas. The gas cannot sustain a reactionary force unless the gas is contained. Okay, and that's it. That's it. The gas just has to be contained to do work, like I've said 100 times in my own video. So, how can I make a gas do work? Well, you fill up a capsule and just pressurize gas into it so that it's like high pressured gas capsule, and then you just chuck the capsule. Then you have the mass of the gas is contained, so you can throw that capsule and you will gain a Newton's third law effect. So that's a way to do it. You have to contain the gas for it to work. And then some people will say, well, inside the combustion chamber, the gas is contained. Correct. The gas is contained inside the combustion chamber. Are you proposing that we throw the combustion chamber off of the rocket in order to do work? That would work. You know, if you have, like I just said, you have a capsule full of gas and you chuck it, you're going to gain that little bit of reactionary force. But unless you're throwing the entire tank, like the tank itself, like the gas has to be contained to apply a force to it. So you have to push that tank away from you. You have to push the entire tank away from you. You can't just say, oh, the gas is contained, but then I shoot it out of the tank. No, as soon as you shoot it out, as soon as you open up a teeny hole or whatever in the tank, the gas is no longer contained. So if you can't push on the gas, then, you know, I hope that makes sense. I mean, just think about it. Just think about it. You have to push on the tank because the tank is the contained gas. There is no contained gas that you're pushing away from you. You know, because you would have to be pushing the container away from you. So I hope that makes sense. Comment below. I'll leave any questions, comments. This is part 6. Rockets do not work in space. Do work.